Hello, welcome to another video in which we'll be talking about limit of detection, how to calculate limit of detection using three standard deviation approach. Before we get started, please help me subscribe to my channel. I thank you for your support. Okay, so limit of detection, there's a couple of ways to calculate it, but in this video, we'll be focusing more on the three standard deviation approach. Okay, let's first look at the formula down here that we have. This is a typical formula that everyone will be using, where the limit of detection is concentration of a blank plus 3 times of the standard deviation of the blank. Okay, so I go through all three items over here to explain the meaning of them because we need to get some kind of understanding before we can really use this formula. Okay, C blank plus 3 times standard deviation. Let's first look at number 3. Why do we have number 3 over here? So number 3 over here is basically, it actually is a one-tailed t value, which is a statistic stat, right? So I don't think we need to get really deep inside why we have 3 or thing like that. But actually, what it dictates over here is actually number 3 will be related to how many runs we need to make and what is the probability that we need to rely on, right? To tell that whether the signal is above the blank level, it is at the detected level, right? Okay, so to understand how many runs and probabilities, I think the best way is for me to show you using Google. So, okay, let me jump right into Google Chrome. Then if you go to Google, you just need to type in something like called T table, something like that, and you can just use any T table that you have. I'm going to use this one. Okay, so down here you have a t-value table right here, and you have on top here something like the probability. Okay, it's 0.5, 0.25, something like that. And the one we are going to use one tail because we don't have the negative side, so that's why we only have the positive side in terms of the concentration. So we'll be using one tail, and we have a DF, which is degree of freedom over here. Okay, so degree of freedom is basically a number of runs minus 1, and if you look at this table, you may need to look for those. Again, if we go back here, we look for this number 3, right? And you just need to search for number 3 or something around number 3 there. So that's, let's say this one is 2.98, which is very close to 3, and that is corresponding to T99, which is 99% probability, and 7DF, which is that means you need 8 runs to to use this one, right? Okay, so that's one way for you to use. Another way I can show you is because I don't want to get into the copyright things like that over here, so I'm going to use Excel to show you how to create that one. Because in Excel we'll be more flexible, where because if you look at back this one, some percentage they don't show up over here. Let's say I want 96% is not here. So I want to use Excel so that I have more flexibility over here. Okay, so typically we always want to perform this calculation with at least 95% probability. Usually we don't want to report lower than that. So I will start the formula from 95% always to 99.99%. But if you want to have lower than that, go ahead and add that yourself. That should be that's very easy. Okay, so the first thing we want to perform calculation over here is because this is the formula in Excel using is something like this, T.inv probability and the degree of freedom. Probability is basically means probability to be wrong. Okay, so that means if you want to calculate 95%, you have to use 1 minus this value over here. Oh, sorry, that should be equal to 1 minus the value up here. So you get 0.05, something like this. So this probability is this number. It's not 95%, right? So take note of that. Okay, I'm going to write over here so that I perform calculation for everything. Okay, so the degree of freedom is just the number of runs over here minus 1. So I have 2 runs, that will be 1 and 3 and so on. Okay, so the formula over here is, okay, so that would be T.inv, and we have the probability over here, which is the one on top here, and then comma, and then the degree of freedom, which is this guy. Okay, close the bracket. Okay, a couple of things we need to do over here is when I drag this one over here, I don't want this column to change, right? So I'm going to lock this column over here, and when I want to drag the formula down here, I don't want this column, this row 3 to change. So that's why I'm going to lock this row 3 as well. Okay, so one more thing is because we are going to do one tailed, so the by default setting might be negative over here, and so that's why I'm going to put absolute over here like this. Okay, and then I'm just going to write everything like here, then I should have the formula of myself, all the values I have. So that basically more or less the same. So let's verify a couple of things. Let's say 95% of 1 degree of freedom, you get 6.31. 1 degree of freedom, 95%, 6.314. So that's we are correct in the Excel over here. So why I like to use Excel over here, because it will give me more flexibility to search for where I get number 3 from. Because just now you see we have to look through this whole table to find number 3, which is sometimes quite hard to find. So what I'm going to do is I just highlight the whole table over here. Then I just go to conditional formatting. Then I can just highlight the cells. Let's say I go to between. Sometimes you don't want to look for the exact number 3. You may want to start from 2.9 and all the way to probably 3.1. You don't want to be so far off 3 in order to use this formula over here, 3 times standard deviation, right? So I'm going to highlight something like this. There you go. So you have a couple of values that will match that criteria where you have 3 standard deviation. Okay, so this is the one, the first one you have. So this, in order to use this one, you need to make 3 runs and at 95% confidence interval. So to me, it's easy, a little bit too few of runs, So 3 runs, that's okay, but to me, I feel a little bit too few. So you could go a little bit higher, like over here, 95% with 4 runs, a little bit better. Or this one is actually we match number 3 nicer way. So you can go to 98% and 5 runs, or 98.5% at 6 runs, or even this one 99% at 8 runs, or something like this over here. So that's a very quick way for you to tell how many runs you should do and at what probability you want to perform this calculation, right? So in this so-called video, I will be demonstrating using this number over here because I have 8 runs in total in my data. So I'm going to use this one, and that will give me 95% probability, right? So I'll be sticking to this in this video, right? So let's go back to the formula here. So that will explain to number 3 over here. Again, that will dictate how many runs and the probability that you want to perform the calculation, right? Okay, so the second term over here is C blank, which is the average concentration. And why average? Because basically on top here, we have made like a couple of runs over here, so that the C blank over here, that will be the average concentration, right? And in order for you to come up with the average concentration, you need to have a valid calibration table, right? Because when you run a blank, what you get from there is an error count, right? You need to convert that error count to concentration before you want to use this formula on top here, right? I will show you that in a second when we get into the software, right? Then the third term is standard deviation of the blank. And because we have a couple of runs here, we should be able to calculate the standard deviation of those runs, provided C blank is not 0. The numbers on top here is not 0. Why? Because if it's 0, then standard deviation will be 0, which is nonsense. It doesn't make sense that you get 0. Then if this one's 0, this one's 0, your LD will be 0, which is not realistic at all, right? So those are the couple of conditions that we need to take note of in case we want to perform this calculation using this formula. And the condition over here, C blank is not 0, so that's why we need to we will be using this formula. But in case your C blank is really 0, I will make another video talking about that. How do we perform the calculation if C blank is really 0, or even we don't have a real blank to run, right? So stay tuned for that video. Okay, so let's go through this one. And again, as I say, number 3 over here, I will be using this conditions where we have 95% and 8 runs. And then C blank over here that we need to make a couple of runs, and then we have the concentration. So let's get into Chemstation. And so these are the sequence that I'm going to have. I'm going to use over here. So you see that I have 8 runs over here. Okay, so that is okay for me to commit to this condition, and the probability I'm going to use is 95%. Okay, so the concentration over here, what that means is you need to have a valid calibration table, and look at down here, I have a valid calibration table down here. And what does mean is when you have one data like this, you simply print the report, and that report will give you the concentration inside the report down here. There you go. You have the amount column over here. You have the concentration, and what you need to do is you copy all this concentration for all these compounds, and you want to put into this run one over here, and then you will do the same thing for run two. Double click on it, report, print report. Okay, then you have the data for the second run down here. Okay, then you just keep repeating for all 8 runs, and then you copy all data into this from run 1 to run 8 over here for all compounds that you have. Okay, and I have done that. I always save the data over here, so I'm just gonna copy this over here, and you see that it's really fast, but actually when you have to go through and copy one by one, that will take quite a lot of time. So if you have more compounds, that will be even more time consuming, right? So once you have done this step, then the average will be just AVERGE, average of run 1 on the way to run 8 over here. And then you have the standard deviation, which is STDEV of 8 runs again. There you go. And then standard deviation, LOD is basically the average plus 3 times standard deviation. There you go. Then you just select all 3 and drag the formula down, right? So there you go. So you have the formula for the LOD values for all these compounds within for these 8 runs, and you can report this LOD with 95% probability or confidence, right? Okay, so that's the way how you do how you use Excel to perform this calculation. And again, if you see, you have to key in up this value over here before you can come up with this calculation, and that will take quite a lot of time for you to do that. Okay, so that's why the idea over here in this video is we're not going to use Excel at all. So we'll be using something called the software we're talking about is Chemstation, Openlab Chemstation intelligent reporting to perform this calculation in a much faster way and a lot more robust, because the number that you key in over here, they basically round up number from the software. So there will be some minor errors from here when you come up with this LD. But if you use whatever number from the software within the software itself, there's no rounding up at all. Okay, so your final value will be a lot more accurate, and better yet, the calculation will be a lot faster. Okay, so let me show you how to do that. Okay, so I will go into this Openlab Chemstation down here, and again, these are 8 runs that I have. Okay, so what I'm going to do is I will highlight all 8 runs, and I will right click, then send selection to report layout. The reason why I like to do this because this will give me the instant preview of my calculation. I don't need to go back to this window to view the calculation. Okay. Okay, so I will be at report layout. There you go. So these are all the data that I just sent over to this report layout preview data. I have all 8 runs on top here. Okay, let me make a new report template for that. So a new report template. Then this will be a single sequence summary because 8 runs belong to the same sequence. So I'm going to select single sequence summary here. And down here, up to you if you want to change anything over here. So I'm going to say OK. Okay, so you can rename this, you can change the new logo if you want to, but in this video I just focusing more on the calculation. So the first item I want to wrap over is I want to have a table of all my 8 runs so that I know which data I'm working with, right? So that will be under sequence and sample summary here, right? Something like this. And if you hit the preview button over here, you have 8 runs over here, right? So that should be easier that you know that you're working with this 8 data, right? Then you go back to edit report template. Then the next item you want to wrap over is go to tables. Then you go to picks and compounds. Then expand it. And then you use compound results over here. Okay, wrap one table over. Then what you need to do is you right click on it, select properties. Okay, go to columns over here. Okay, so if you look back this one, we just need to have the concentration. We don't need anything else. So I'm going to remove everything, something like this. Height, I'm going to remove. RF, I'm going to remove. Then it will be like this. Okay, let me show you how it looks first. Okay, so there you go. So you have iron sulfide of all 8 runs, and they are all inside a single table here, and all COS in a single table, something like this. And this will not give you anything, valuable at all. So what I'm going to do over here is I'm going to right click again. What I would like to do is I want to add someone to show me the order of my let's say run 1, run 2, run 3, run 4, run 5, run 8, right? So I want to add another column over here to increase visibility of my table. So I'm going to add that under sample, and I can add something called sample acquisition order number over here. So it will be something over here. Okay, and then in the sorting, I also can sort my table using sample acquisition order number. So that will be showing me like 1, 2, 3, 4, 5, 6, 7, 8, right? So let me show you that. Preview. There you go. So you have 1, 2, 3, 4, 5. So this is run number 1, and you have all all of these compounds over here. And then you have run 2, all compounds over here, something like this. But again, there's still like everything inside a single table. So what I'm going to do is I'll show you the magic over here. Let me show you that. Let me open this a little bit bigger to make things nicer over here. Something like this. Okay, so right click on it again, select properties. Okay, let's go back to this formula for a while. So you need to have the average and you need to have the standard deviation to perform this calculation, right? So we go back to this one, go to columns, then you go to our mouse over here, select column properties, and then you want to do the average and you want to do the standard deviation calculation over here. Then you need to save this, because as you see there's no LOD calculation over here, so that's why you need to save these two variables first. Yeah, for the average, I can call it ABE or whatever you want to put in. Standard deviation, I can call it STD or something like this. Then I'm going to say OK. And then I'll say OK from here, right? So it will look something like this. Preview. Okay, so you have again all of this number over here, and then at the bottom that you have the average and standard deviation of all compounds over here. So let me show you the magic of using Openlab Chemstation intelligent reporting. First of all, let me add the LOD formula in, so you can select go to fields, then you can select any of these fields. It doesn't matter because we're going to change the formula anyway. So go to label. You can add in like this one, you can call it LOD. Then in the value, you can put scroll down here, select FX over here, then delete this. Okay, then you go to variables. Just now we save AVE and standard deviation over here. So the formula is average plus 3 times standard deviation. Right? Okay. And say okay. And then you want to format your value a little bit to have probably want to have 3 decimal places, something like this. Say okay. All right. So something like this. Let me move this a little bit over. Okay, something like this. All right. So the magic over here is you want to select both the LOD formula and the table on top here. Right click on it, select group. Okay. And then you right click on the group over here, somewhere over here, select properties. And this is the group properties over here. And the grouping and group repeat over here, you go and select compound name. Compound name, okay, something like this. Say okay. So what does it do? It will kind of like repeat for every compound name instead of put all compounds in a single table. Okay, say okay, and then preview. Okay, there you get something like this. There will be something on top here, but you need to worry about that one. So it will look something like this. There you go. You have iron sulfide, run 1, run 2, run 3, on the way to run 8 over here. Then you have the average value over here. then you have a standard deviation, then you have the LOD calculated for you right here, right? And then we'll be repeating for COS down here, carbonyl sulfide, the same thing over here, and then it will also perform calculation for every single compound in this way. So you see that within a few clicks, the calculation will be done automatically for you. You don't even need to, copy of this number into Excel like the one I did just now, right? So you can add a little bit more information into this, like this LOD doesn't say anything. So you can add something like, go back to edit report properties, select this field over here, and go to label. You can also put in a formula for this table, which is equal to, let's say I want to have to be LOD off. You want to show the compound name, something like this, then and compound name, something like this. Okay, so what happened is it will be something like this. Let me show you. There you go. So for hydrogen sulfide, we say LOD of hydrogen sulfide 0.054, LOD of carbonyl sulfide 0.039, something like that. Okay, and if you don't even want to show this table, that should be fine as well. You can just go to the table over here, right click on it, select properties, go to advanced, and then uncheck the visible box down here. Say OK, review. There you go. So it's kind of like a quick summary of like iron sulfide, what's the LOD, blah, blah, thing like that. So I think it's very nice to show something like this, a very quick calculation. So once you're happy with the calculation, simply go to File and say Report Template As. You can say whatever name you want. I can pick this one. Okay, save it. Then you can go back to data analysis, and the final step is to assign that report template into the method that you are working with to perform a calculation for you. Okay, so you go to sequence over here, sequence parameters, and then you go to sequence output. You check the print sequence summary report over here. The one we created just now is called intelligent reporting, so it's down here. To browse and select the template just now that we created. That is LOD3SD over here. Bring it over, say OK, and then down here you can select whatever option that you want to, or you even want to print the individual reports down here, but I don't want to do anything of that. I just want to preview at the end of the sequence. Let's say OK, then I save the sequence, then I can process the sequence hitting this button down here. Then the software just go through one by one, and then at the end it will provide it will come up with something like a summary report where you have all the LOD value inside. Okay, we take a few seconds to process all of these runs. Okay, reports coming up. Okay, there you go. So you have 8 runs that we are using to process our data, and this is the report down here. So very quick, you have the LOD of all of this, right? So that's a very quick way for you to calculate the LOD using this 3 standard deviation approach. Okay, so that's pretty much everything I have in this video, and as I say, stay tuned to my next video where I'll be talking about another case where the C plan is really 0. So you have no plan at all. So how do we tackle that problem? Okay. So thank you very much for watching, and I hope you enjoyed this video, and I will have another couple of videos at the end of this video so that you can keep on watching to learn more about all of these techniques. Okay, and if you have any question or any comments, let me know in the comment below. Otherwise, I will see you next time. Right, thank you very much for watching, and do not forget to subscribe to my channel. Thank you. Bye bye.